Okay, this time it's factored. Factored pretty nicely there in the denominator, so I don't have to mess around with that any. I can just go straight to setting this up. I know that the top does factor, but that isn't going to come into play here. Not something I need to worry about. It's really just the denominators. So I set this up, and I have to do this so that I use every possible type of denominator that we can get. So I use a over x, b over x squared, and c over x minus 1. And I have to do an x minus 1 squared and an x minus 1 cubed. And then when I multiply by the common denominator and get rid of everything, the left side will just become x cubed minus 8. Just an x cancels out with the a, so it's left with x times x minus 1 cubed. Then this, and then here with the c, well, I get c times x squared times x minus 1 squared. And finally, over here at the e, I'm just left with the x squared. So this is a much longer one that we're starting with. I'm still going to go through and let x equal 0 to begin with. And that gets rid of any terms that have just a plain old x in it. So it's going to get rid of the a term, the b term, the c, the d, and the e. So I'm left with, will not get rid of the b. I misspoke there. So I'm going to get 0 cubed minus 8 is equal to b times 0 minus 1 cubed. So negative 8 equals negative b equals 8. So I get that. Then I can go ahead and let x equal 1. And that's going to get rid of any term with an x minus 1 in it. So that'll get rid of the a, the b, the c, and the d. And I get 1 cubed minus 8 is equal to e times 1 squared. So negative 7 equals e. So I've got e, I've got b. That still leaves me with a, c, and d. So what I'm going to do is I'm going to go ahead and plug in the b and the e into this equation right here. So right here, this becomes b8 times x minus 1 cubed. And over here at the end, I'm going to have a minus 7x squared. At this point in time, I'm going to start, I want to move some stuff around. So it's this right here, this term right here. I want to multiply that out. Everything else is going to stay the same for a moment. But what this one's going to become is that to start with. I've got a couple of things backwards there. Yeah. And then I would say that I would change the last term as well, but there's nothing to do there with distribution. So it's going to stay that. And then I'll go ahead and finish distributing here. So None of this is super tricky on the algebra front. It's all things that we know how to do. It's just that there is a lot of it. And then I'm going to start to collect some like terms and move some things around. So I am going to take and subtract the 8x cubed over. I'm going to add the 24x squared. I'm going to subtract or add the 7x squared, subtract the 24x, add the 8. The minus 8 was already there. And then everything else here with the A and the C and the D all stay here. Collect some like terms here on the left side. Negative 7x cubed plus 31x squared minus 24x. And the 8's add to 0. And what happens there on that left side, I'm going to start to factor this. So I factor out a negative x. I will take, and this quantity will factor. And I'm looking for two things that work with that 7. It happens to be that it is a minus 1 and a minus 24. So it's like that. Now, looking at this, what I have here is everything, both sides have an x in it and an x minus 1. So I'm going to divide everything by an x times x minus 1. And that's going to give me negative quantity 7x minus 24. And on this side, it simplifies things down a little bit. To that point. Now, because it's in this little bit simplified form, I can let x equal 0 again. When I let x equal 0 again, on the left side, I get negative times a negative 24. And on the right side, the c term and the d term will both drop out. So I'm left with this. So that means that a is equal to 24. And again, I can let x equal 1. On the left side, I plug that in. On the right side, that will make the a term and the c term drop out. It'll make both of those zeros, and I'm left with d times 1 squared. So on the left side, I get a positive 17, and then I get d. So d is equal to 17. Now, just like I did on the previous problem, I'm going to let x be something different. I, again, would pick a 2, and I will let plug that in, and I'm also going to let my a be a. The c I don't know yet, but I do know that d is 17. So I plug into x, I plug in the a and the d, and then I go through and I do a little bit of solving out here. None of it is, again, too terribly bad, but there is a little bit of just arithmetic involved in that. And when I do that, oh, I made a mistake here that I didn't catch earlier. It doesn't make a difference with A or D, but that should be a squared, not be a squared. That shouldn't be a squared, which means that shouldn't be a squared. D is still 17, but it does make a big difference there. So that's 34. And that's because when I divided by an x, I should have canceled out up there, and I forgot. 58 plus 2c, negative 48. And then c is equal to negative 24. So at this point, I've got all of my letters. I've got A, I've got B, I've got C, I've got D. And I can just rewrite my fraction as 24 over x plus 8 over x squared plus, I'm going to put a minus 24 over x minus 1 plus 17 over x minus 1 squared, and then minus 7 over x minus 1 cubed. This problem had a lot more work. That's what happens. The more that we have in the denominator, the bigger we have to use, the more we have to split it up, and the more algebra steps that we get involved in that.